Solving systems of equation using elimination. This is the third and final way that we are going to be looking at systems of equation. Steps in solving linear systems using elimination. Step 1, you first need to multiply one or both equations to create a pair of opposite coefficients. So maybe your x's, one of them's positive 5 and the other's negative 5. Maybe your y's have positive 6 and negative 6. Number 2, add the two equations together. One of the two variables will be eliminated since they have opposite coefficients. Solve for your remaining variables since you have eliminated one of the variables. At this point, you'll know one of the variables. Maybe x equals 17, y equals negative 2. You'll know one of the variables. Once you know that, substitute that variable back into your equation, one of your original equations, and solve. Example 1, we have 2x plus y equals 20 and 6x minus 5y equals 12. We need to multiply one or both of the equations to create a pair of opposite coefficients. It's not going to matter which coefficients which variable we get rid of. Either one will work. So for example, I could go ahead and look at my x's and change them so we have a positive 6 and a negative 6. Those would be the least common multiple and be the opposites. Or I could have negative 5 and positive 5 with the y's. Both methods are going to work. It does not matter which you choose. To keep our numbers just a little smaller, I'm going to go ahead and eliminate the x's. I've already got one equation with 6x. I just need the other equation to be a negative 6x. So to do that, I'm going to multiply both sides of my equation by a negative 3. So that gives me the equations 6x minus 5y equals 12. The top equation, when I distribute my negative 3, is going to be negative 6x minus 3y equals a negative 60. From here, we're going to add our two equations together. You want to make sure all your variables are lined up. So my x's are in a line, my y's are in a line, my equal signs are in a line, and my equal to, my numbers by themselves, are in a line. So I'm going to add both of these together. 6x minus 6x, well, that's just 0, so those cancel out. Negative 5y minus 3y is going to be negative 8y. 12 plus negative 60, let's see. Negative 60 plus 10 would be negative 50. I've got two more, so that's negative 48. Solving for y, I'm going to divide each side by negative 8. And we will end up with y equaling a positive 6. So now we've done steps 1 through 4. Our remaining step is to go back and substitute this y equals 6 into one of the two equations and find x. So it's not going to matter which equation we choose. I'm actually going to choose the top equation. Since y is almost completely by itself anyway, it's going to make life a little easier. So I'm going to have 2x plus y, but y is 6, so I'm going to change that to a 6, equals 20. Subtract 6 from each side. We have 2x equals 14. divide both sides by 2, and x equals 7. Since x is first in our ordered pair, we have the ordered pair 7, 6. I'm not going to take the time to show you checking it right now, but you can check this ordered pair by substituting 7 in for x and 6 in for y in both equations and making sure it works. For example 2, I've got negative 2x plus 6y equals 6 and negative 7x plus 8y equals negative 5. We're going to have to multiply both equations in order to get a coefficient that's going to work. I can't just multiply one equation by something and get integers that are going to work nicely. So this time, instead of concentrating on getting the x's to eliminate, I'm going to concentrate on getting the y's to eliminate. To get the y's to eliminate, I need them to be opposite coefficients. So between 6 and 8, I could use positive and negative 48, but we can actually get there quite a bit faster if we use positive and negative 24. It does not matter which equation is the positive and which one is the negative, whichever one's easiest for you. I'm actually going to make the bottom equation the one that I multiply by a negative, because that's going to eliminate the negative 7, or the negative sign in front of the 7, and the negative 7 in front, or the sign in front of the 5. So I'm going to go ahead and multiply my bottom equation by negative 3 on both sides. The top equation, to get a positive 24 for y, I'm going to multiply both sides by a positive 4. So multiplying that out, for the top equation, 4 times negative 2x is negative 8x. 4 times 6y is a positive 24y. And that's going to equal to 6 times 4 is 24. The second equation, and I'm going to go ahead and change the color on that just to make it a little easier to see. The second equation, the bottom equation, when I distribute the negative 3. Negative 3 times negative 7 is a positive 21x. Negative 3 times positive 8y is going to be minus 24y. Negative 5 times negative 3 is going to be a positive 15. We've got our x's lined up, our y's lined up, our equal signs, and our constants lined up as well. So step number 2, I'm going to add the two equations together. Negative 8x plus 21 is 13x. (24 minus 24 is 0. So that will cancel out. And 24 plus 15 is 39. So that 24 and negative 24 cancel. So we've got 13x equals 39. Divide both sides by 13. And x equals 3. I'm going to put that x equals 3 back into one of my two original equations and solve for y. Again, it does not matter which equation you choose. I'm going to just choose the top one. It looks like a nice enough equation. So I'm going to have negative 2x, but I'm going to take out x and put in 3 instead, plus 6y equals 6. Negative 2 times 3, that's going to be a negative 6 plus 6y equals 6. Then I'm going to add 6 to each side to get rid of the negative 6. That leaves me with 6y equaling 12. Divide both sides by 6. And y equals 2. Again, you can go through and take your ordered pair. Let's see, the x is 3, the y is 2, so you can take the ordered pair 3, 2 and test it in both equations to make sure it works. Let's see, negative 2 times 3 is negative 6. 6 times 2 is 12. Negative 6 plus 12 is 6, so it works. Negative 7 times 3 is negative 21. 8 times 2 is 16. Negative 21 plus 16 is negative 5. So it works for both equations. 2 homework problems for you tonight. Good luck, and we'll see you tomorrow.